Have you ever wondered why we can't live on Mars? Mars, the red planet, has always been a topic of fascination and curiosity. This mysterious neighbor of ours in the solar system has been the subject of countless missions and research projects. Scientists from all over the world are tirelessly working to unravel its secrets and explore the possibility of life. The allure of Mars is undeniable. It's a planet that's close enough to reach, yet far enough to present a tremendous challenge. Its red, rocky landscapes, towering volcanoes, and massive canyons capture our imaginations and fuel our dreams of interplanetary exploration. However, despite its close proximity and intriguing features, Mars is not a welcoming place for humans. The conditions there are harsh and the environment is inhospitable. The challenges that make Mars uninhabitable are numerous and significant. Despite its appeal, Mars remains a harsh and inhospitable planet for humans. And here's why. Firstly, the atmosphere on Mars is drastically different from that on Earth. Let's take a moment to dive into what makes it so unique and challenging for us humans. You see, the air we breathe here on Earth is mostly composed of nitrogen, at about 78%, and oxygen taking up about 21%. The remaining 1% is a mix of argon, carbon dioxide, and traces of other gases. Now, contrast this with the Martian atmosphere, which is made up almost entirely of carbon dioxide, at a whopping 95%. The remaining 5% is a collection of nitrogen, argon, and a smattering of other elements. Notice something missing? Yes, you got it. There's virtually no oxygen. Now, it's not just the lack of oxygen that's problematic. The Martian atmosphere is also incredibly thin, with a surface pressure less than 1% of Earth's. This thinness presents a double whammy of challenges. First, it means that any oxygen we were to bring with us would quickly dissipate, making it impossible to breathe without some form of life support. But it also means that the atmosphere provides little protection against harmful solar radiation. Here on Earth, our thick atmosphere acts as a protective shield, absorbing most of the sun's harmful rays before they can reach the surface. On Mars, however, with its thin atmosphere, much more radiation reaches the ground. This radiation can cause serious health issues, including an increased risk of cancer. So even if we could somehow overcome the breathing issue, we'd still be faced with the challenge of protecting ourselves from this harmful radiation. To put it simply, the Martian atmosphere is not our friend. It lacks the oxygen we need to breathe and the protection we need from the sun's harmful rays. It's a harsh, inhospitable environment that presents significant challenges to human habitation. In essence, the Martian atmosphere provides neither the air we need to breathe nor the protection we need from harmful solar radiation. Water, the elixir of life, is scarce on Mars. Imagine Earth without water, a barren, desolate planet devoid of life. That's Mars for you. While the red planet does have water, it's mainly in the form of ice, hidden beneath the planet's surface and at the polar ice caps. The Martian environment is just too cold and the atmospheric pressure too low to allow for liquid water to exist on the surface. The moment it tries to materialize, it either freezes solid or evaporates right into the thin air. It's a harsh reality that makes the prospect of harvesting water on Mars an incredibly challenging feat. Now you might be thinking, well, we can just melt the ice, right? Not so fast. Accessing this frozen water is a monumental task in itself. It's not like we can just send a rover with a giant ice pick to chip away at the Martian surface. We'd need advanced technology and vast amounts of energy to extract and melt the ice into usable water. And that's just the tip of the iceberg. This lack of easily accessible water has far-reaching implications for human survival on Mars. Water is not just essential for drinking, it's vital for growing food, maintaining hygiene, and even producing oxygen to breathe. It's also a key ingredient in making rocket fuel, which would be crucial for the return journey to Earth or for powering a potential Martian colony. Moreover, water plays a critical role in regulating climate and temperature. Without it, Mars remains a frigid desert with extreme temperature swings, from a maximum of 20 degrees Celsius at the equator during the day to minus 80 degrees at night. In essence, the scarcity of water on Mars is a major roadblock to human colonization of the planet. It's not an insurmountable obstacle, but it does make living on the red planet a much more complex proposition than just packing up a spaceship and setting course for our celestial neighbor. Without easy access to this vital resource, survival on Mars would be a formidable challenge. Mars's weather is another barrier to human habitation. This statement sets the tone for our exploration into the harsh realities of the Martian climate. The red planet is not just a world of breathtaking crimson landscapes, it's also a world of extreme temperatures, ferocious dust storms, and an eerily absent magnetic field. Let's start with temperatures. Mars is incredibly cold with average temperatures around a negative 80 degrees Fahrenheit. In the height of summer near the equator, it might reach a comfortable 70 degrees Fahrenheit, but at night it can plummet to a bone-chilling negative 100 degrees. Such extreme temperature fluctuations could pose serious challenges to human health and the functionality of life-supporting equipment. Next up, dust storms. Mars is infamous for its planet-wide dust storms, which can last for weeks or even months. These storms are so massive that they can be seen from space, and they're not just a sight to behold. The fine dust particles can infiltrate equipment, potentially damaging vital systems. Imagine trying to maintain a habitat or a life support system in these conditions. Then, there's the lack of a magnetic field. Earth's magnetic field protects us from harmful solar radiation. Mars, however, lost its magnetic field billions of years ago. This means that anyone living on Mars would be exposed to higher levels of radiation, which could lead to serious health issues like cancer. Additionally, the absence of a magnetic field means that Mars has a very thin atmosphere. This thin atmosphere doesn't retain heat like our Earth's atmosphere does, contributing to the planet's frigid temperatures. It also means that Mars has virtually no weather as we know it. No rain, no snow, just a constant dry, cold wind. In short, the weather conditions on Mars are hostile to both humans and the technology we would need to survive. If we ever hope to call Mars home, we'll need to find innovative solutions to these formidable challenges. Lastly, living on Mars would mean dealing with low gravity and extreme isolation. Picture this. Mars has only about 38% of Earth's gravity. That's less than half. Now you might think, hey, that sounds fun, bouncing around like an astronaut on the moon. But the truth is, our bodies are designed for Earth's gravity. In a low-gravity environment, our muscles and bones start to weaken. This is known as muscle atrophy and bone demineralization. Over time, without regular and intense exercise, we could experience significant muscle loss and our bones could become brittle. And that's just the physical side of things. With isolation, it's a whole different ballgame. Imagine being millions of miles away from everyone you know with only a small crew for company. The psychological impact of this isolation can be severe. Feelings of loneliness, depression, and anxiety could become commonplace. People need social interaction. It's a fundamental part of our well-being. On top of that, there's the communication delay with Earth. Due to the vast distance between Earth and Mars, it would take anywhere from 4 to 24 minutes for a message to travel one way. That's right, a simple hello could take up to 48 minutes to say and hear a response. Now imagine dealing with an emergency situation with that kind of delay. It's like being on hold with customer service, but with potentially life-threatening consequences. In these conditions, even simple tasks would become arduous, and the risk of serious health issues would increase significantly. So, while the idea of living on the red planet might seem exciting, the reality is fraught with challenges. It's not just about survival, but about maintaining our physical and mental health in an environment that is fundamentally not designed for us. But who knows? With advances in technology and our understanding of the human body, perhaps one day we'll find a way to make life on Mars a reality. So why can't we live on Mars? Let's recap. We've delved into the allure of the red planet, a world of iron oxide landscapes and alien sunsets. But we've also faced the harsh realities of a hostile atmosphere, thin and primarily carbon dioxide, unable to support our human requirement for oxygen. We've considered the scarcity of water, a vital resource for life as we know it. We've braved the Martian weather, a whirlwind of extreme temperatures and intense dust storms. We've felt the effects of low gravity, a force that could potentially wreak havoc on our bodies. And lastly, we've grappled with the reality of isolation, being millions of miles away from our home planet. While Mars is a fascinating planet, it's clear that the challenges of living there are currently insurmountable. Perhaps with future technological advancements, humans might one day be able to call Mars home.